Dear students, welcoming you to my YouTube channel Learning Island. Today I am representing you the video number 3 with numerical solution from exercise 8b. In this video you can watch total 5 solution. So there is a series of videos on the numericals, so you can go through or watch all the video. So let us start without any delay. This is the question number 1. Here the given data, I always suggest you to write down the given data. That will solve the problem half. So here you see the diagram in the figure shows a cell of e.m.f, that is electromotive force E is epsilon. So given right here, given epsilon equal to 2 volt and internal resistance, that is R equal to 1 ohm, connected to external resistance R equal to 4 ohm. So external R equal to 4 ohm. The emitter A measures the current in the circuit and the voltmeter B measures the terminal voltage across the cell. What will be the reading of the emitter and voltmeter when number 1, when the circuit is closed, the key is open, that means circuit is closed. We know if the circuit is closed there will be no flow of current, so the emitter reading will be 0. Now what will be the voltage in the voltmeter, because the voltmeter is connected here in the terminal of the cell. So in the cell we know there is a formula, that is E minus current into internal resistance is equal to voltage across the battery, which will be shown in the voltmeter. So as circuit is open, so the current is 0, so 0 into internal resistance, it is given 1, so 0 into 1 equal to V. So and the value of E is 2 minus 0 equal to V, so V equal to 2. So the voltmeter reading in this case will be equal to 2 volt. Now the second case, when the circuit is closed, that is when the circuit is closed, then a current will pass to the circuit. So when the circuit is closed, let current is I. So here the total resistance will be of circuit is equal to, you see, the internal resistance R plus the external resistance capital R. So that will be small r plus capital R equal to, small r is 1 and capital R is 4, so 5 ohm. So the resistance is 5 ohm and the voltage is from the battery is getting E. So here to find out the current we can use the formula like this. If I calculate it here, we know current equal to V by voltage by resistance. So here voltage is how much? 2. Total voltage applied is 2, because it is EMF divided by 5, because total potential difference here is E, that is the EMF of the battery, and the total resistance in the circuit is 5, so it will be V, Ohm's law, V equal to IR. So we are getting what? We are getting current is 2 by 5, that is 0.4 ampere. So current is 0.4 ampere, and what will be the voltage? So now voltage will be equal to, in the voltmeter is connected against the battery, it will be V equal to E minus I into small r. So E given 2 minus 0.4 into voltage is resistance is 1 ohm. So we are getting 2 minus 0.4 equal to 1.6 volt. So in second case, the ammeter reading will be 0.4 ampere and the voltmeter reading will be 1.6. Hope it is clear to you, so we can get the final solutions here. You see the current is coming 0.4 ampere here, and the voltage is coming in the second case 1.6. In the first case the current was 0, because there was no the circuit was open, and the voltage is equal to the EMF 2 volt. So hope this is clear. And I go to the next question, question number 2. Here you see, again you write down what is given. So the question is a battery of EMF. So EMF is given, so epsilon is given, it is equal to 3 volt. Supplies a current through a circuit in which resistance can be changed. Here you can change the resistance. So suppose this is the battery, and there is two cases. One is because the resistance is changeable. So this is the internal resistance, this is the EMF, and this is the R1. So this is the actually total battery. Now, so in first cases given, when the current is 1.5 ampere, a high resistance voltmeter is connected across the battery when the current is 1.5 ampere. So the voltmeter reads 2.7 volt. Find the internal resistance of the battery. So here we will have to find out the internal resistance of the battery. What is given? A high voltage at a high resistance voltmeter is connected. That means there is a voltmeter connected over here, that is, it is a voltmeter connected over here, and voltmeter has no resistance. Voltmeter has a high resistance, so there will be no current flow. Voltmeter has high resistance, so there will be no current flow in the voltmeter. Now when it is connected with a resistance, external resistance R1 equal to when current, the voltmeter is 27, find the internal resistance of the battery. So here what happened, a little bit correction is needed. I am again doing the circuit. Just 1 minute. Eraser. If I erase this one, the circuit is like this. You can see here. Yeah, it looks like this. This is the battery, and this is the internal resistance R, and here they have connected a voltmeter which has no resistance. So this is the actually battery. So in this case, the resistance voltmeter is connected. The current is I equal to 1.5 ampere, and voltmeter reading V equal to 2.7 volt. So what is the resistance? So here I can apply V equal to E minus I into R, because there is no external resistance, because in the voltmeter it is a high resistance there. So only it will be calculated like this. V equal to V is 2.7 equal to E. E is given 3, so you can put 3, and IR. I is also given 1.5, and R is not known. So here you see in the circuit there is no external resistance. So we can directly apply V equal to E minus IR, because in the 2 point of the battery there is only working the e.m.f and the internal resistance. So the we can find out here is R equal to 2.3 minus 2.7 divided by 1.5. So I am getting what? I am getting 0.3 divided by 1.5. So it is finally 3 divided by 15 equal to 1 by 5, means 0.2 ohm. So R is 0.2 ohm. So hope it is clear. So you can find out the final solution here. This is like this. Here you see the 3 volt, that is the e.m.f, which is given. I have shown you in the earlier slide. So I is 1.5 and V is 2.7. So it is simply formula V equal to E minus IR. So you have got this 2.2 ampere. So go to the next slide. You can pause the video and write it down as per your convenient. So I am going to the next video, question number 3. So again write down the given data, so the problem gets easier to you. A cell of EMF 1.8 volt. So again here E equal to EMF equal to 1.8 volt, and the internal resistance, that is small r, equal to 2 ohm, is connected in series with the emitter of resistance 0.7. Here you see the resistance of the emitter R1 equal to 0.7 ohm, that is ohm, and another resistance R2 equal to 4.5. So here this is R1 and this is R2, and this is small r, and 1.2 is EMF. So it is clear to you, I think. So the total resistance of the system is, if I calculate the first question number A, what would be the reading of the emitter? So in emitter we get the current flow. So we will have to find out the current, amount of current. So to get the amount of current, we will have to find out the total resistance of the system. So the total resistance of the system is, I will have to, because all these are connected in series, so the total resistance R will be R1 plus R2 plus small r. That is, we can write R1 is 0.7, R2 is 4.5 plus 2 ohm. So if I add, I will get what? 5 to 7.2 ohm. 7.2 ohm. Now we can easily find out the current, the circuit. So we know from the Ohm's law, V equal to IR. So here I will be E, because here the potential difference is 1.8 volt, that is the EMF. When I divide this with the equivalent resistance, that is 1.8 by 7.2, so I am getting 1 by 4 finally after cutting. So I am getting 0.25 ampere current. So the first question, what would be the reading of the ammeter? The answer will be 0.25 ampere. What is the potential difference across the terminal voltage? So that will be, I can find it out very easily in the, what is the potential difference across the terminal. So the formula is, again I am calculating here. So here you see, in the terminal voltage, what is the potential? That will be the formula is again similar. It is V equal to E minus I into R. This is a very important formula. You'll have to remember it, memorize it, then you'll be able to find out all the solutions. So here the voltage against the battery would be 1.8 minus I is 0.25, and the resistance is what? 2. So it will be 1.8 minus 0.5, that is, we are getting 0.3 volt. So the answer of the second, the potential difference across the terminal of the cell is 0.3 volt. So let us see the final answer here. So I think it is, yeah, it is, there is some mistakes. It will be actually 1.3, because if I deduct 1.8 from this, I will get 1.3. So this is 1.3. So please write it down. Now we can go to the next questions. Question number 4. A battery of EMF 15 volt and internal resistance 3 ohm is connected to two resistors of resistance 3 ohm and 6 ohm in series. Find the current through the battery and the potential difference between the terminal of the battery. It is similar to the previous question. I think you would be able to find the solution. So please pause the video and try it yourself. I hope it will be very easy. So let us do it right now. Hope you have tried after pausing the video. So again, what is given here? The given data is EMF equal to 15 volt, and the internal resistance, that is small r, equal to 3 ohm. Now it is connected in series with the resistance of 3 and 6 ohm in series. So the circuit will be like this. This is the battery and the internal resistance is R, small r. So this is the total battery, and this is connected with two resistance in series. So one is R1, one is R2. Here R1 equal to 3 ohm, R2 equal to 6 ohm. So in the first question A, the current to the battery. So current, to find out the current, we have to find out the equivalent resistance. So here the equivalent resistance R is equal to R plus R1 plus R2. So that will be R1 is given, smaller is given here 3 ohm plus 3 ohm plus 6 ohm. So finally it is getting 12 ohm. So the equivalent resistance of the circuit is 12 ohm. 3 plus 3, 6 plus 6, 12. So from the Ohm's law, V equal to IR, we can easily find out the current in the circuit. So that is V by R. V is here EMF 115 volt and R is 12. So this is coming what? 3 5s are 3 5s are and it is 3 4s are. So finally I am getting what? 3 4s are 3 5s are 5 by 4. So 5 by 4. The result is coming 1.4 on the 5. That is 10 4 10 4 to the 8 5 5 4 to the 8 20 4 5 the 20 4 to the 8 20 1.25 ampere. So the current is 1.5 ampere. So the first answer, question answer, current I equal to 1.25 ampere. Now the next question, the PD means potential difference between the terminal of the battery. Again we can use this. So if it is V, if the potential is V, then we can write E minus I into R. Same formula. So E is 15 volt minus I, we know 1.25 into R, smaller is 3. So it is coming 15 minus 3.275. So if I subtract this 5 2 2 and here will come 11. So it is 11.25 volt. So hope this is clear to you. So please write it down, the final solution. Here you see. So hope this is very clear to you. Now we can go to the next video without any delay. So this is the question number 5. Again write it down. Write down the given data. That is what is given here is we can go like this. Given, it is come. So we can write it down. Given data is what? Yes, a cell of EMF E, that is E given E, don't know what is the value. The internal resistance R, also don't know what is the value. The current I is 0.1 ampere when it is connected. So that is current I1. It is connected with a resistance 1.9, that is R1 equal to 1.9 ohm. But it sends, this is another case, second case, I2 equal to 0.5 ampere when connected to the resistance R2, that is 3.9 ohm. So there is two cases. This is the battery with internal resistance small r and it is E epsilon. So this is the battery. It is connected, in first case, connected with a resistance of R1 equal to 1.9 ohm. So current passes through the circuit is I1 equal to 0.1, not 0.1, it is 1 ampere. I have written here, it is 1 ampere. Now in second case, is the battery, small resistance. So this is the battery. It's connected with another resistance. This is smaller. This is epsilon. This is R2 equal to 3.9 and current I2 equal to 0.5 5 ampere. So we'll have to find out what is the value of EMF and internal resistance. So in first case, if I consider the total current I1 will be epsilon that is EMF minus EMF by small r plus capital R1. So on simplification I am getting E by small r plus 1.9 and this is equal to 1 this is equal to 1 ampere. So this is equal, this is the equation number 1. From the second case we are getting I2 equal to what? I2 equal to epsilon E by R plus R2. So this will give small r plus 3.9. So this is equal to 0.5. This is equation number 2. So if I divide equation 1 by equation 2, so dividing equation 1 by equation 2, we get what? I1 by I2 equal to R plus 3.9 by small r plus 1.9. So I1 by I2, I1 is 1 ampere, I2 is 0.5 ampere. So we are getting 10 and 5, so it is getting equal to 2. So if I simplify further it, so 2r plus 3.8 equal to r plus 3.9. On further simplification we are getting r equal to 0.1 ohm. So now if I put the value of r in equation number 1, we get what? We get E by 0.1 plus 1.9 equal to 1. On simplification we are getting equal to 2 volt. So hope this is clear to you. So go to the final solution. It is given here. So please pause the video and write it down. I hope the solution for these 5 numericals you have understand it very clearly. So if it is really helpful to you, please subscribe my video and subscribe my channel, and also forward this video to your friends so that they can also get the benefit out of it. Thank you all for remaining with me, and I will see you again in my next video. So if you want to see the previous videos, video number 1 and 2, you can watch it very easily because I have given the links in the descriptions. So today, thank you, bye bye.